This is Brian or Lightman to show you my new rocket test stand that will allow me to test small rocket thrust and impulses. My design is a derivative of the elemental maker Nick Sequino and Len Johnson's designs. This Arduino-based system uses a 10 kilogram load cell to measure thrust. During the test, data is collected via the laptop and a USB cable. I have made modifications that include an arming and disarming system for the igniter, a 7-segment display, and a warning light. Finally, I made modifications to the graphical user interface that allows the operator to run the entire test from the laptop. Using a 50-foot active USB cable, the operator can sit comfortably at a safe distance. After attaching the clips to the igniter, the system is armed with a switch, and then continuity is checked with the blue LED. A hinged cover protects the electronics from any overblast from the rocket motor. Here's a schematic that shows all the interconnections of the key components. The micro-rocket motor design comes from the King of Random. It comprises 3 pieces of sugar fuse encapsulated in a chamber made of foil. This is then reinforced with electrical tape to create the nozzle and the chamber body. I then attached one of my custom E-matches to the main fuse. The 2 pigtails will then be connected to the clips of the rocket test stand. The test setup outside includes the laptop control station, a 50-foot active USB cable, and the rocket test stand off in the distance. The rocket test stand sits behind a plexiglass blast shield. The countdown timer and the warning light are set off to the side. The motor under test is slipped into the tube, and the E-match pigtails are then attached to the clips. The igniter enable switch is flipped on, and the blue light confirms continuity. Back at the control station, typing a letter A and hitting enter starts the test. As shown here in this demonstration, A is pressed, and then the countdown starts to count from 9 down to 0 and then ignites the igniter. Once the igniter starts, data collection begins at 80 samples per second, measuring the thrust in gram force. Data collection lasts for 9 to 10 seconds. The data from the serial monitor was copied into Excel and then plotted. The x-axis is time in samples at 11.4 milliseconds per sample. The y-axis is thrust in gram force. The micro-rocket generated just under 100 gram force thrust at about 5 seconds in the timeline. Examining that spike more closely, we see about 24 samples of effective thrust available. Integrating the area under the curve, we see that the total impulse is 0.048 Newton seconds. Although that doesn't seem like much, these micro-rockets are known to shoot up about 100 feet. The rocket motor itself only weighs a gram, so it experiences about 100 Gs of acceleration. End of demo.